Welcome to this GCSE Maths revision video on linear sequences and nth term. A linear sequence is just a set of numbers that goes up or down by the same amount from one term to the next. Left hand side of the screen, here's an example of one, and on the right hand side of the screen are the typical questions that you would be asked at GCSE level. So let's take a look. We're given the first four terms of a sequence and we're asked to work out what the next two terms are. This, hopefully, you'll find pretty straightforward. All we need to do here is look at the sequence and work out what it is going up by. So let's have a look. From term to term, have we seen the pattern already? This is going up by 4. So if we were to extend that sequence, the next would be 18, and the one after that would be 22. So pretty straightforward mark there. Now if we look at the next type of question we're going to get, nth term stands for any term, and this in this we're going to write an expression that allows us to find any term without having to count all the way up to that term. So have a look at how we do that. We've already identified that our sequence is going up by 4 from one term to the next. So what do we know that also goes up by 4? It's the 4 times table, isn't it? The 4 times table goes 4, 8, 12, 16. So it goes up by 4. So from that we write 4n. Just become a convention that we use the letter n. So we know that our sequence is based on the 4 times table because it's going up in 4s. To complete this, we now need to look at what we call our 0 term. So if our first term is 2, we ask ourselves, if we went one term to the left, what would this term here be? So as our sequence is going up by 4 from left to right, if we went one term this way, this number here, we subtract 4, would be -2. So -2 is what we call our 0 term, and we'll put that here. So from that, our expression for the nth term is 4n minus 2. Let's have a look at how you would put that to use. Use your nth term expression to find the 50th term. I put 50th in brackets there because it's just an example. You could be asked the 20th, the 30th, the 100th, but as long as you understand the method, you should be fine. We take the value that we're given and we substitute it in place of n. So instead of writing 4 times n, I'm going to write 4 times 50, take away 2. So 4 times 50 is 200, subtract 2, and we get the answer 198. So without counting all the way up to the 50th term, we've used a bit of algebra here to work out what the 50th term is going to be. So typically those would be the three parts of a GCSE question on this. If I now move on to another one, pause the video if you want to have a go at it. Otherwise, watch out for the solution. So, term to term, it's going up by 3. So, from that, we write 3n. If we went one term to the left, what would our 0 term be? Well, it would be 4. Now, unlike the previous example, this 4 is still a positive 4, isn't it? Because we're still in positive numbers. We haven't crossed over from positive to negative numbers. So this time we write 3n plus 4. So now we come to write an expression, written expression. Now we come to use our expression to find the 50th term. Substitute 50 in the place of n, like so. And we've got 3 times 50 plus 4. That's going to give us 154. So hopefully that makes that clear, what we need to do there. Slightly trickier is when we get a descending sequence. I've seen some students get a bit confused about what they need to do. Important thing to note, when the sequence is going down, here we must write -5, yeah, not +5. So this sequence is actually based on the -5 times table. So we write -5n. Please don't write 5n for this, otherwise it's going to go wrong. We still look one term to the left for our 0 term, which would mean adding 5, so we get 23 there. So our nth term expression is 5n plus 23, minus 5n plus 23. So when we come to use that, again slightly trickier because of the negative numbers, so it helps to be on top of doing arithmetic with negative numbers. I'm going to write -5 times 50 add 23. Now -5 times 50 is going to give us -250. Yeah. Negative times a positive gives us a negative answer. And if we add 23, please don't make the common mistake of saying that the answer is going to be -273. We're at -250 and we add 23, that's us moving back towards 0. So if you add 23 to that, your answer is going to be -227. So that's our answer. 50th term of this sequence would be -227. Last thing I want to show you is you might get asked, is a particular number a term in the sequence? Asked to explain how you know that. So I'm going to use nth term for this. This is the same sequence as 2 slides ago. So yeah, going up by 3. So we had an nth term expression of 3n plus 4 because our 0 term was 4. So to find out if 59 is in this sequence, we take our expression and we make it equal, so we make an equation using the value we've been given in the question, and then we try and solve the equation. So if you are on top of solving linear equations, that's good. I have got a video on this, and lots of other math teachers have got videos on this, so I'm not going to go into too much detail here. I'm trying to get the 3n on its own, so if we subtract 4 from both sides, we're going to get that 3n equals 55. Then to get n on its own, we would have to divide by 3. Now 55 is not in the 3 times table, so that division by 3, I did that on a calculator, that's going to give me 18.3, and the 3 is going to be recurring. So if you get asked this type of question, if you solve the equation and you get a whole number here, an integer, then the number is in the sequence. But if, like the example here, if you don't get a whole number, that's enough to tell us that 59 is not in the sequence. That's it for this video. Thank you for watching and listening. Bye.